This is lesson 6.3, reference angles. So a reference angle is what we call alpha, is an acute angle formed by the terminal side of the angle in the nearest x-axis. So make sure you don't get it confused and try to draw it just to the nearest axis whatsoever and do it to the nearest y-axis, because it's always the nearest x-axis. So looking at our coordinate plane, keep in mind that our quadrants, we've got our quadrants labeled 1, 2, 3, 4, and what we look at here, that all 6 trig functions are positive in quadrant 1. So we look at this as, we kind of label this as quadrant A, or another way that we label it is quadrant A. Sine and its inverse cosecant are positive in quadrant 2, and we call that one S. Tangent and its inverse cotangent are positive in quadrant 3, and cosine and secant are positive in quadrant 4. And one way that I was taught to memorize this, this is just a little phrase way back when I was in school, is Appalachian State Teachers College. And I know Appalachian is a university and not a college, but a lot of people go to App to become teachers. So that's just one way that I was taught to memorize that, to remember the ASTC. You may come up with your own way, but it's something that's always worked for me. Okay, so let's practice finding the alpha angle. So we're going to sketch the angle. And when we draw our angle, we always start with it on the positive x-axis. And if we're going to sketch 100 degrees, we know that it's going to go past 90 degrees. Here is going to be 180, so we know it's not going to go quite that far. So 100 degrees is going to be about right here. Now, let's zoom in here a little bit. So alpha is going to be this angle right here. So this is the alpha angle. So it's this distance between our terminal side and the closest x-axis. This is the closest x-axis. So we're trying to figure out the distance between the terminal side and the closest x-axis. So remember, this was 100 degrees. And basically, what is the distance from 100 to 180? Well, that is 80 degrees. So our reference angle is 80 degrees. So looking at our next one, now this one's negative. We're still going to start on the positive x-axis. That's where we're going to start. And 90 degrees is going to be here. Negative 180 is going to be here. So we know we're not going to get quite to 180. We know it's going to be somewhere over here. But our reference angle, we know, is going to be here. So I'm going to label this negative 150. But in here, let's see, in here is going to be alpha. So if this is negative 150, how much further does it go to get to 180? Well, that would be 30 degrees. And our reference angles are always positive. Okay, so it's the distance from the terminal side to the x-axis. The distance is always positive. Okay, so looking at our next one. So we start here. We are going positive, so we know it's bigger than 90, bigger than 180, bigger than 270, but we know it's not going to be it's not going to be as big as 360. So we know it's going to go all the way around. It's going to be somewhere in here in quadrant 4. So this is where 320 is going to land, and our reference angle is going to be here. So 320, so we got to think, okay, what is the distance from 320 to 360? And that would be 40 degrees. Okay, so now let's move to radians. So radians, I'm going to go ahead and change this to a mixed number. So that's going to be 1 and 1/3. So if I start here on my positive x-axis, so 1 is going to get me all the way around to pi here. 1/3 is not going to put me past 3 pi over 2. So I know I'm going to land in quadrant 3. So alpha is going to be here. So let me go ahead and label this. This is 4/3 pi. I'm going to have to zoom out a little bit. Looks like it's not cooperating. So I know I went, so I'm thinking in terms of radians. From here to here I know was 1. And I basically went 1/3 past that x-axis. So if it was 1/3 past the x-axis, but then we have to put a pi back in there. Let's see here. Let me erase that. So pi over 3 radians is my alpha, or is my reference angle. Okay. Oops, I meant to click on the eraser. Okay, so again here, I'm going to start out here. I'm going to go ahead and change this to a mixed number. So 6 will go into negative 13. That's going to be negative 2 times, and I have 1/6 left over. So I've got negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. I'll throw in my 0 there. So negative 2 pi, I'm going to go around, here's negative 2 times, and 1/6. So my alpha is going to be here. So let me label negative 13 pi over 6. So right there is alpha. So I know I went 1/6 past it, but that would be pi over 6. I got to put my pi back in there. Radians. Okay, and then my last one, I'm going to go ahead and change that to a mixed number. So that 3 will go into 22 7 times with 1 left over. So 7 1/3. So I know that over here is pi, and if I go all the way around, that's 2 pi. So I'm going to have to go around 7 times. So if I think this is pi, if I think 3 pi, 5 pi, 7 pi. Okay, so I'm going to end up over here, and then 1/3 is going to put me right here. So my alpha is going to be here. So alpha is going to be pi over 3 radians. And if I do draw this angle, I know that here's 1, 2, 3. Let me redo that. I was counting too many times there. I wasn't counting my 2 on the other side. So let me start that over. So there's 1, 2, 3, 4, 5, 6, 7, and then there's my angle. Let me draw my alpha right there. Okay. All right. So on this next one, we're going to state the value of all 6 trig functions for each angle. So the first thing we have to do is we have to figure out what the reference angle is, because negative 60 is not on our trig chart. We have 60 on our trig chart, but we don't have negative 60. So the first thing I'm going to do is I'm just going to sketch negative 60. Well, I know negative 60, negative 90 is down here, negative 60 here. Well, my reference angle is a positive 60. Okay, so that wasn't too hard to figure out. But what we have to take in consideration is this. Okay, so it lands in quadrant 4. which means if it's in quadrant 4, that means when I look up on my trig chart, the only ones that are going to be positive are cosine and secant. So that means my sine, cosecant, tangent, and cotangent, I have to make those negative. Okay, so when I look up on my trig chart, the sine, I don't know what is going on. Sine of negative 60 degrees. But what I'm actually going to look up on the trig chart is I will look up sine of 60. But I have to make it a negative because of where it landed. But the sine of 60 is square root of 3 over 2. All right, cosine of negative 60. But I'm going to look up the cosine of 60 is 1/2. And it's going to stay positive because it landed in its own quadrant. All right, tangent of negative 60. So when I look it up on the trig chart, it's going to be negative square root of 3. And it's negative because it did not land in its quadrant. So cosecant of negative 60 is going to be negative square root of 3. Secant of negative 60 is going to be 2. And cotangent of negative 60 is going to be negative square root of 3 over 3. So the important thing here is to make sure that you get your signs correct. Okay, so when we do this one, if I graph 5 pi over 6, so we start here. So 5 pi over 6, here is pi over 2, and this is where pi would be. So 5 pi over 6 is going to be here. My alpha is going to be here. So if you got to think, okay, well, what's the distance left to get to pi? Okay, well, you think what plus 5 over 6 makes it a whole? Well, that would be 1/6. So pi over 6, just put that pi back in with the 1/6. So our alpha angle, or reference angle, is pi over 6. Now, if I draw in my ASTC, I'm in quadrant 2, or S. I've already got the S mark. So the only ones that are going to be positive are sine and cosecant. Cosine, secant, tangent, and cotangent are going to be negative. Okay, so let's see here. So sine of 5 pi over 6, when I look it up on the trig chart, I'm looking up, I use pi over 6. So when it tells you to look these up, find the exact value, especially when it tells you to look it up without a calculator, when you get your reference angle, it should be something on your trig chart. If it's not something on your trig chart, that's a good indicator that you've messed up. So sine of pi over 6, when I look that up on my trig chart, it's going to be 1/2. Cosine of 5 pi over 6, so I'm actually looking up the cosine of pi over 6. It's going to be a negative. I'm going to make it a negative, but when I see it, it's square root of 3 over 2. Tangent 5 pi over 6, and I'm going to go ahead and put my negative down so I don't forget it. But I'm looking up the tangent of pi over 6, square root of 3 over 3. Cosecant of 5 pi over 6 is going to be a positive 2. Secant of 5 pi over 6, and I know this has to be a negative, so it's going to be 2 square root of 3 over 3. And cotangent of 5 pi over 6, it's also going to be negative square root of 3. All right, 7 pi radians. So if I graph this one, so I'm starting here. Well, 7 pi over radians is odd. So I know it's going to land over here on this side. So here's 1, 2, 3, 4, 5, 6, 7. So it landed right here. So it's the same as pi. So since it's the exact same as pi, since it actually landed on the axis, we don't have to worry about our signs. Okay, we just look up whatever it is. So the sine of 7 pi is 0. The cosine of 7 pi is -1. The tangent of 7 pi is 0. The cosecant of 7 pi is undefined. The secant of 7 pi is -1. And the cotangent of 7 pi is undefined. And so for all these, we're just looking up on the trig chart, the sine of pi, cosine of pi, and so on. Okay, so more like this, if I'm doing 225 degrees. So 225 degrees, over here is 180. This is 270. I know that it's going to be over here. So here's my alpha angle. So if this is 225, how much further is past 225 than 180? So I would just do 225 minus 180. So that means my reference angle is 45 degrees. I'm in quadrant 3, where tangent and cotangent are going to be positive. Okay, so sine of 225, I know this is going to be a negative, but I'm going to look up the sine of 45, square root of 2 over 2. Cosine of 225, so again, I know this is going to be a negative. I look up the cosine of 45, square root of 2 over 2. Tangent, I know, is going to be a positive since it's in quadrant 3. So it's going to be 1. Cosecant of 225 is going to be a negative, square root of 2. Secant of 225 is going to be a negative, is square root of 2. And cotangent, I know, is going to be positive, and it's going to be a 1. All right, radians, we're back to radians here. So 2 will go into 7 3 times. So this is like saying 3.5. So if we start out here, so here's pi, 2 pi. So 3, this would be 1, 2, 3. And it's going to land here. Okay, so this is like 3 pi over 2. So that's like 1.5. So our half is always like on an axis. So this one is the same as 3 pi over 2. So when it lands, again, when it lands on the axis, we don't have to worry about the positives or negatives. You just look at it and take it as it is. So our sine of 7 pi over 2 is going to be -1. Cosine of 7 pi over 2 is going to be 0. And again, I'm just looking up 3 pi over 2. That's what I'm looking up on the chart. Tangent of 7 pi over 2 is going to be undefined. Cosecant of 7 pi over 2 is going to be -1. Secant of 7 pi over 2 is going to be undefined. And cotangent of 7 pi over 2 is going to be 0. Okay, last one like this, 330 degrees. So here's 180, 270, and 360. So if we start here, I know it's going to end up over here. So alpha is going to be in here. So if this is 330, how much further from 330 is it to 360? So that would be 30 degrees. Our reference angle is 30 degrees. So we're using 30 degrees. Now, as far as the quadrant, This is quadrant 4, so cosine and secant are going to be the only ones that are positive. So the sine of 330, I know it's going to be negative, so I'm looking up the sine of 30, which is 1/2, and I've already got my negative there. Cosine of 330, this one is going to be positive. I'm looking up the cosine of 30. It's going to be square root of 3/2. Tangent of 330, this one's going to be negative, so I'm going to put my negative down. Square root of 3/3. Cosecant of 330 is going to be negative 2. Secant of 330, oh, forgot my degrees, is going to be a positive, so it's going to be 2 square root of 3/3. And the cotangent of 330 is going to be negative square root of 3. I know it's negative because it's in the cosine quadrant. Okay, so on these, state the quadrant in which each angle lies. So here's how I like to do these. I like to draw my quadrant. Okay, so it tells me sine is less than 0. It tells me sine is negative. Okay, well, I know sine is positive. I'm just going to put like a tiny little dot. I know sine is positive here and here. Okay, well, that tells me sine will be negative here and here. All right, well, tangent, then it tells me tangent is greater than 0. So that means it's positive. Well, out of these two that I have marked now, which one is tangent positive in? Well, tangent is going to be positive in that one, in the one that's marked T. So my answer is going to be quadrant 3. Okay, so if I get it narrowed down to 2, and then between the two, for like my final clue, I guess you could say, which one is it between those final two? Okay, so on this one, all right, cosine is positive. Well, which two is cosine positive in? Cosine is positive in the one that's marked all, and cosine is positive in this one. Well, then it tells me cotangent is positive. Well, remember, cotangent goes with tangent, and it says cotangent is positive. Well, between these two that are marked, which one is tangent or cotangent going to be positive? Well, it can only be positive in that one. So it's in quadrant 1. All right, so on our last one here. Okay, so remember, cosecant is the inverse of sine. Okay, so it's the inverse of sine, so it's positive. So that goes, it's positive in quadrant 1, in quadrant 2. And then secant goes with cosine, and it's negative. Well, out of these two, where is secant going to be negative? Well, secant's going to be negative in the sine quadrant. So our answer to that one is going to be quadrant 2. Okay. Finding the value of something that like would not be on the trig chart. Okay, so we have these formulas. So sine is going to be y over r. Cosine is x over r. Tangent is y over x. Cosecant is r over y. Secant is r over x. Cotangent is x over y. There's a way to memorize this. This is pretty easy. So I'm going to slide this over real quick and write it over here. So, and I'm just going to write it short, kind of shorthand. So remember, sine and cosecant are like inverses of each other. Cosine and secant, tangent and cotangent. So if you can just simply remember that sine is y over r and cosine is x over r. If you can memorize those two, then you'll have the rest. So if you memorize those two, then tangent is y over x. Okay, you take those two, it just goes in order. And then the other ones are just going to be flipped. Okay, so cosecant, flip sine, r over y. Secant, flip your cosine, r over x. Cotangent, flip your tangent, x over y. And that's it. That's how you memorize them. Okay, so back to doing this. So you're given sine and cosine, find the exact value of the other four. So if this is sine, that means that this is y, this is r. If this is cosine, this is x, this is r. Now, if sine is positive, cosine is negative, that also means you're in quadrant 2. And so I don't necessarily like to worry about like the x is negative. I just say, okay, if sine is positive, cosine is negative, I know I'm in quadrant 2. So I need to know, or I know my x and y, and I'm just going to list them out to the side. I've got x is 3, y is 4, r is 5. And I'm not going to worry about positive and negative because if I'm in quadrant 2, sine and cosecant are the ones that are positive. Tangent, secant, cotangent are all going to be negative because I'm in quadrant 2. Okay, so I'm going to do cosecant of theta. So like we said, cosecant is r over y, and I know it's going to be positive, so 5 over 4. Secant of theta is going to be my r over x, and I know that's going to be negative, so negative 5 over 3. And then I'm going to do my tangent and cotangent. So my tangent is going to be y over x, and it's going to be negative, so 4 over 3. And cotangent is just going to be negative 3 over 4. Okay, so if this is sine, this is y, r, x, r. So I have x is 1, y is 2 square root of 2, r is 3. And if sine is positive, cosine is negative, again, I'm in quadrant 2. So the only ones that are positive are sine and cosecant. So cosecant is going to be 3 over 2 square root of 2. Now, we can't have a radical on the bottom, so I have to rationalize my denominator. I'm going to multiply top and bottom by square root of 2 over 2. I don't know what happened there. So that gives me 3 square root of 2. Now, remember, when you multiply two radicals, that just goes away. That's going to become a 2. The radical cancels itself out. So now I have 2 times 2, which is 4. All right, secant is going to be r over x. So that's going to simplify, which is negative 1. So that's going to simplify to negative 3. All right, then if I do tangent, which is y, so 2 square root of 2 over x, so negative 1. Or, well, that was negative. So that's just going to simplify to negative 2 square root of 2. And then cotangent will be negative 1 over 2 square root of 2. And again, I have to rationalize my denominator. I'm going to multiply top and bottom by square root of 2 to get rid of that radical. So I'll get negative square root of 2. And then remember, that's going to turn into a 2. So I'll get negative square root of 2 over 4. Okay, so for our last example, we're going to find the exact value of the remaining trig functions. So if this is cosine, remember this means this is going to be x and this is going to be r. Now we don't know y. But to find y, we just basically use Pythagorean theorem. So I have 3 squared plus y squared equals 5 squared. So if I do 5 squared minus 3 squared, that means y squared equals 16. So y is going to be 4. Now, it also tells me that we're in quadrant 4. So the only ones that are going to be positive are cosine and secant. So sine of theta is going to be y over r. So negative 4, I don't know what this is doing. So negative 4 over 5. Cosine, I already got that. That's already given. And tangent is y over x. So negative 4 over 3. All right. Cosecant is going to be negative 5 over 4. Secant will be a positive 5 over 3. And cotangent will be negative 3 over 4. All right, on this one we have sine. So here's y and r. So I'm going to need to find x. So I have x squared plus negative 2 squared equals 3 squared. So be careful with that negative. Make sure you put parentheses around it. So if I subtract, if I do 3 squared minus negative 2 squared, I'll get x squared equals 5. And if I take the square root of that, I'm just going to write that as a square root of 5. We're not going to use a decimal for that. Now, this one tells us that theta is between pi and 3 pi over 2. Remember on our graph, this is where pi and 3 pi over 2 are. So if it's between these two, it's in here. So it's going to be in quadrant 3. So the ones that are going to be positive are tangent and cotangent. Those are the ones that are going to be positive. So sine of theta, negative 2 or 3, which we were given. You don't have to write that down. You don't have to give that. Cosine of theta is going to be x. It's just going to be negative. So it'll be square root of 5 over r, which is 3. And tangent, this one will be positive, y, which is 2 over x square root of 5. Now, I can't have, we talked about that, can't have that, so I'm going to multiply top and bottom. So we'll get 2 square root of 5 over 5. Okay. Cosecant of theta is negative 3 over 2. And secant of theta will be negative 3 over square root of 5. And again, we can't have that, so I need to rationalize my denominator by multiplying top and bottom by square root of 5. So we'll get negative 3 square root of 5 over 5. And my cotangent of theta will be square root of 5 over 2. And that will conclude these notes.